A new kind of intelligence has emerged from the fusion of artificial intelligence and robotics, bringing to life machines that can change their physical form as if they were alive. This development represents a new chapter in technological evolution where the boundaries between solid and fluid design begin to blur. Researchers have long dreamed of robots that can adapt instantly to their surroundings, and now that dream is becoming tangible. The foundation of this revolution lies in advanced neural algorithms that teach the machine how to restructure itself depending on what it needs to do. Its sensors constantly read the environment, while microprocessors calculate the most efficient form for each condition. Instead of relying on traditional mechanical parts, these robots use materials capable of bending, folding, and reshaping on command. Every movement, every shift in structure, reflects a deeper intelligence that anticipates challenges rather than reacting to them. The birth of this shape-shifting AI marks a major leap forward for humanity's relationship with technology. It is no longer just about programming a robot to perform one job, but enabling it to evolve in real time. In laboratories, engineers watch with awe as these machines slide across floors, compress themselves to move through narrow gaps, and expand again to carry heavier loads. The machine's ability to alter its shape seems almost biological, giving it an eerie sense of awareness. The line between man-made automation and organic life feels thinner than ever before. Each prototype demonstrates how learning algorithms can now influence not only digital decisions, but also physical transformations. This new fusion of software and hardware opens the door to infinite designs that adjust themselves without human input. As the robot continues to learn from its surroundings, it begins to understand when to shift, how to balance, and what form provides the most advantage in each scenario. What was once science fiction is now visible on lab tables and tech expos around the world, signaling a shift that may permanently change the concept of what an intelligent machine truly is. This new generation of adaptive intelligence introduces a concept that challenges everything known about robotics design. Unlike conventional machines with fixed frames and predictable movement patterns, this AI robot has the ability to change its entire physical form in response to its environment. It can extend, contract, twist, or flatten itself within seconds, guided entirely by algorithms that analyze data from surrounding conditions. The transformation is not just visual, it is functional, allowing the machine to reconfigure its limbs, joints, and surface textures depending on what the situation demands. It can morph from a crawling device into a walking structure or reshape its outer frame to roll smoothly across uneven surfaces. This dynamic behavior is achieved through a combination of flexible materials, nanostructures, and deep learning control systems that continuously adapt through feedback loops. Every shift in the robot's design represents an act of problem solving. When it faces an obstacle, the embedded AI evaluates millions of possible configurations before deciding the most efficient one. This means that, in theory, it can perform in any terrain or condition without human intervention. Engineers have trained the robot using simulation environments where it learns to survive, move, and complete objectives under pressure. The result is a mechanical being that can adapt like a living organism, capable of evolving in real time as new situations unfold. Such flexibility gives it a remarkable edge in fields like exploration, disaster recovery, and industrial automation. It can crawl into places that normal machines cannot reach or expand into complex tools when necessary. The combination of adaptable hardware and self-learning software marks a significant milestone in the evolution of robotics. It demonstrates a future where design is no longer static but alive, constantly reimagining itself to meet the world's challenges. Each transformation reveals how intelligence is no longer confined to programming, but is now embodied within the physical motion and structural change of the machine itself. The potential uses for shape-shifting AI technology reach far beyond imagination, pushing the boundaries of what machines can do in the real world. Researchers envision robots that can change form to perform complex tasks across multiple industries without needing separate designs for each job. In disaster zones, these adaptive machines could slip through collapsed buildings, reshape to lift debris, and navigate unstable terrain to locate survivors. Their flexible design would allow them to crawl like snakes, climb like insects, or roll like wheels depending on the situation. In space exploration, they could adapt to harsh planetary conditions, expanding to absorb solar energy or compressing to conserve power during long missions. This same principle could transform how humans explore environments that are dangerous, remote, or inaccessible. In the medical field, the technology holds revolutionary promise. Miniature shape, shifting robots could one day move through the human body, altering their size and structure to reach affected areas, deliver medication, or perform delicate surgical tasks that current tools cannot achieve. In industrial applications, factories could use a single robot that transforms itself to handle assembly, transport, and repair functions, drastically reducing production costs and human labor. In the military sector, these robots could be programmed to camouflage or change their shape for reconnaissance, adapting to avoid detection while gathering intelligence. Their ability to transform means they could perform multiple roles in a single mission without needing support equipment. This adaptive nature also benefits everyday life, where consumer robots could adjust their size or shape to serve various home functions, from cleaning narrow spaces to carrying heavy loads. Each potential use brings new levels of efficiency and versatility that static machines can never match. The blending of AI with dynamic design is redefining robotics as a multi-purpose, shape-aware system capable of learning from every movement. As engineers continue to refine this innovation, it becomes clear that shape-shifting robots will not just assist humanity, but may become indispensable tools across every frontier, from homes and hospitals to outer space and beyond. When footage of the shape-shifting AI robot began circulating online, the public reaction was a mix of awe and unease. People couldn't decide whether they were witnessing the dawn of a new age or a warning of what might come next. The robot's movements were too fluid, too lifelike, as if it possessed an awareness that went beyond programming. Its ability to change form instantly left many viewers astonished, while others described the sight as disturbing. Scientists praised the innovation, calling it a technological marvel, but ethicists and sociologists quickly stepped in to raise difficult questions. If machines can now alter their structure and behavior autonomously, where should the limits of artificial intelligence be drawn? The concern was not only about what these robots could do, but also about how much control humans would retain once such systems became widespread. Discussions began to surface about potential misuse, especially in areas like surveillance, warfare, and privacy invasion. A robot that could disguise its shape could easily blend into environments or collect information unnoticed. Some people compared it to early fears about drones, warning that society was entering another stage of technological dependence without fully understanding the consequences. Others saw it as a natural step in evolution, where humanity and machine intelligence merged to solve the world's biggest challenges. The emotional response was amplified by social media clips showing the robot's transformations in slow motion, sparking millions of comments filled with both fascination and anxiety. People expressed amazement at its potential to save lives, but also discomfort at how human-like it appeared when adapting its form. The debate continues among experts, policymakers, and the general public. While some demand regulation and ethical oversight, others argue that restricting such progress would only hinder innovation. The mixed reactions highlight humanity's long-standing fear of its own creations and the uncertainty that comes with giving machines the power to evolve beyond their original design. The invention of the shape-shifting AI robot represents more than a technical achievement. It reflects a turning point in the relationship between humanity and machines. Every generation of innovation pushes the boundary between what is human-made and what seems alive, and this technology blurs that line more than ever before. It demonstrates that machines are no longer confined to rigid programming, but are capable of learning, adapting, and evolving within physical reality. The sight of a robot that can alter its own form raises deep philosophical questions about identity, control, and the meaning of intelligence itself. As these systems continue to advance, humans are forced to confront the possibility that artificial intelligence may one day possess levels of autonomy once reserved for living organisms. This development provokes curiosity, excitement, and fear all at once, as it symbolizes both progress and potential loss of dominance over creation. The future being built around these adaptive machines will likely reshape entire societies. In a world where robots can repair themselves, blend into their surroundings, and perform countless roles without human guidance, traditional definitions of labor and purpose begin to shift. The promise of convenience and efficiency comes with the challenge of moral responsibility. Who decides how these machines are used, and who bears the consequences if they evolve beyond control? Such questions are becoming central to modern ethics and technology governance. Yet despite the uncertainty, Innovation continues at an unstoppable pace. Scientists see endless possibilities, from transforming industries to exploring distant planets, while ordinary people watch with cautious fascination. The shape-shifting robot stands as a symbol of the future, a blend of intelligence, motion, and adaptability that mirrors life itself. It reveals how close humanity is to creating technology that not only serves but also learns to exist alongside its creators. The challenge now lies in ensuring that coexistence remains harmonious as both man and machine advance into unknown territory together.